Hi, hello, how are you? My name is Annaton Benson. Welcome back to my channel. I realize I did not do the last few days of the July LeetCode or JuleetCode challenge recorded because I was traveling. So we're starting this on day 26, which is question number 1870, the minimum speed to arrive on time. So when I submitted this, we had a rough go of it. We struggled. We did not do great. There's definitely stuff I want to revisit and improve upon. I really want to try to make this so it's like at least 50% or over on both memory and runtime. But we're going to go over the solution nonetheless. Because in this solution here, or in this kind of metric KPI here, we did get an effective solution eventually after 1, 2, 3, 4, 5, 6 wrong answers. So I'm assuming other people had the same problem that I did. If they didn't, fine. If you guys are, looking through this and you're like, oh, this is the question I'm going to do, you can do this better. I guarantee you. But I wanted to go through my solution and kind of explain it kind of line by line, or like group by group, or function by function rather. So let's go through the question. I'm going to read the question, but I'm not going to go through the examples and constraints. So let's jump into it. So you are given a floating point number hour, representing the amount of time you have to reach the office. To commute to the office, you must take n trains in sequential order. You are also given an integer array dist of the length n, where dist I describes the distance in kilometers to the ith train ride. Each train can only depart at an integer hour, so you need to wait between each train ride. For example, if the first train takes 1.5 hours, you have to wait an additional 0.5 hours before you can depart on the second train ride at the 2-hour mark. Return the minimum positive integer speed in kilometers per hour that all the trains must travel at for you to reach the office on time, or -1 if impossible to be on time. Tests are generated such that the answer will not exceed 10 to the 7th, and hour will have at most 2 digits after the decimal point. So then they give you the examples down here and then the constraints. So first off, I messed it up with kilometers. We're not going to talk about it. It's part of being American that I do not love. So let's jump into this solution. This first area that you see here and here, this is what comes preloaded on the page when you get there. And I can show you actually. Hold on, give me 1 second. So this is what comes. I just deleted this part because it just felt a little redundant at that time. So as I put that back in here, we start with ceil, or like the ceiling, which basically defines a helper function ceil that returns the ceiling value of the given number x, if you can see here, which is the smallest integer greater than or equal to the original x. So we then go to this area where it checks the length of the dist, or distance, list, and it's greater than or equal to the hour plus 1. So if it basically means if there are more distances to travel than the given time allows, so the function returns the -1. From here to here, we initialize 2 variables, left and right. Left starts at 1. Right is calculated as the ceiling of the maximum value between the maximum distance in dist and dist -1 over 1 if the hour integer is, or if the hour is integer. Else this area. So this is essentially setting up an upper bound for the speed, as speed is distance divided by time, right? So we then go into this area, which is a binary search loop. to basically find the minimum speed that we need to travel the distances within a given time. So it basically just repeatedly calculates the middle point, which would be the mid here, and the left and right. And then it calculates the time required to travel each distance at those given speeds, and checks if the total time is less than or equal to the given hour, like here. And then if the right is bound, like if it's right bound, it updates the mid otherwise. Otherwise, the left, it's left bound, and it's updated to mid +1. And then we just return after the loop has been completed, the binary search loop has been completed, we return the value of left, which basically represents the minimum speed needed to travel the distances in a given time. So I hope this kind of makes sense. Basically, we just use the binary search code or binary search approach to find the minimum speed required to travel a given distance or a set of distances within a specified time. So while I didn't do great on the submission part of this, I hope I explained the logic okay. I know I fumbled up a little bit, but I really did struggle with this one. And they said it was, I think, medium. But to me, it was actually super hard. And I don't know if other people kind of feel the same way. But if you've done this problem, I would love to know your solution and like just see what you did. But other than that, I have the GitHub repo for all of my LeetCode solutions down in the video description link below. Feel free to fork and clone, make it better, make it worse, have some fun, learn something new. And that's what this is all about. So I will probably do another video later on. It's not going to be for some time where I rework this because I do want to spend some time reworking it, just because that's important to me. I really want to do better. My goal is to get as many LeetCode problems done as I can, and then to make them over 50% on runtime and memory, just because that's a good challenge for me. So thank you guys for watching, and I will see you guys in the next video.